Hi guys, welcome back to the channel. So today we are going to be solving today's Leetcode question, which is minimum falling path sum 2. So we are given a grid which will consist of n cross n grid, and then we need to return the minimum sum of falling path with non-zero shifts. So let us take one example and then try to figure out the minimum path which is present in this particular grid. So we need to pick each element which is present in the row. Suppose let's say if I pick one, and then we should pick five, and then we should pick seven. So there can be different possibilities, but we need to make sure that each row will consist of at least one element which is present in this particular row. Either we can choose one or we can choose two, and then we can choose three. And then suppose let's say I chose one. Now I cannot choose four. Why? Because it is in the same column. So we should choose the elements such that the adjacent rows should not contain same column. That means I cannot choose 1 4, and I cannot choose 2 5, and then I cannot choose 3 6. I can choose 1 5, I can choose 1 6, I can choose 2 4, and I can choose 2 6, and then I can choose 3 5, and then I can choose 3 4. So these are the different possibilities which I can choose. Suppose let's say if I choose different possibilities, I need to make sure that I'll get the minimum value which is present in this grid. So suppose let us take, we'll take one, and then we can take two, and then we can take three. So these are the different possibilities. Suppose let's say if I pick this particular index, this is going to be our minimum path, and then this is going to be our minimum path sum, and then this is going to be our minimum path sum. Now I want to take 4, which is present in this column, and then with this particular row. Now if I take 4, now I need to consider the path sum of 2 or path sum of 3. Out of these two, 2 is the minimum, so that's why I'm going to choose it as 6. And then here there is an item called 5. So for this we can choose 1, and then we can choose 5. Out of these we can choose 1. Why? Because this is the smallest element, so this is going to be 6. And then let's say we'll take again 6. For this 6 we can choose 1 or 2. 1 is minimum, so we are going to choose that. So now it is going to be 6 6 7. Now 7 has a possibilities that we can choose 6 and then 7, so we are going to choose the minimum element which is 6. So it is going to become 13. And then for 8 it is going to become like 6 plus 4 is going to be 14. 6 plus 8 is going to be 14. And then if we choose 9, then we are going to choose 6, then it is going to become 15. And then out of these rows we are going to choose the minimum value which is 13. So we are going to return this. So for this we what we are going to do is we are going to take all the elements which are present in the grids, and then whenever we are doing for each row, suppose let's say I'll choose the row. I'll choose the row from 0 to n minus 1, and then whenever I'm choosing the column, after choosing the column, I need to consider all other columns which are not equal to this particular column. So I'm going to take k, which is going to be another column which will not be equal to this column, and then we are going to take the maximum, and then we are going to use it. So suppose if we take this loop, so row is going to take big of n, and then column is going to take big of n, and then k is going to take big of n. So this is going to be n cube time complexity. So we need to optimize this particular approach. That's why we are going to remove k, and then we are going to store the prefix and then suffix, where suppose let's say I want the minimum element which is present with this index without this element. So what I'm going to take is I'm going to take the prefix of I minus 1, and then I'm going to take the suffix of I minus 1. That we are going to get the minimum element which is present with this prefix, and then we are going to get the minimum element with the suffix. Suppose let's say we have 5. Now we are going to take the minimum of 5 and then 3 for this, and then for this it is going to be only 5. So that's how we are going to get the minimum value for each index. Suppose let's say for this 6 I'm going to take suffix. For this it is going to be 2, so that's why I'm going to use 2. And then for 5 we are going to use another suffix which is going to be 3, and then we are going to use prefix out of this we are going to take the minimum, and then we are going to use in the answer, and then at last we are going to take this answer, and then we are going to maintain the minimum, and then we are going to return the answer. So let us see the code for this. So we are going to have two things. One is going to be current, and then next is going to be our next iteration, whatever the elements which are present with this path, and then prefix is going to store the minimum element which is present till that index. So if I say I, it is going to be the minimum of 1 to I, and then for suffix it is going to be minimum of I to n minus 1. And then we are going to take answer as int maximum, and then we are going to pick I equal to 0, I less than n, and then I plus plus, and then we are going to take j equal to 0, and then j less than n, and then j plus plus, and then we are going to choose the temp as int maximum. This temp is going to give the minimum element which is present in the previous row. So we are going to take the prefix of j minus 1, and then we are going to take the suffix of j plus 1, and then we are going to calculate, and then if the temp is not equal to int maximum, then we are going to assign next of j equal to grid of ij plus temp. Suppose let's say if temp equal to int maximum, that means we are going to have only one row. Then we are going to take next of j is going to be grid of ij, and then if it is the last row, then we are going to maintain the answer, and then we are going to return the answer. And then one more thing we need to calculate is the suffix, where it is going to take the next of I n minus I minus 1, and then we are going to consider suffix of n minus 1 n minus I for each index, and then we are going to calculate the prefix as well, and then we are going to assign current equal to next, and then at last we are going to return the answer. For this, the time complexity is going to be big of m into n, and then the space complexity is going to be big of n. Yeah, that's all for this video. Thanks for watching the video.